Okay, welcome to lesson 2 of Forces 2. So this is actually this lesson here, velocity, time graphs and acceleration. So if you wouldn't mind, if you please date your work up here, please, so we know when you did it. Velocity, time graphs and acceleration. I can recall and apply the formula for acceleration, change in velocity and time. I can recall the SI units for acceleration. I don't know what that is for. I will know how to interpret a velocity time graph and calculate acceleration. So to get us going, look back in the last lesson, see if you can underline the vectors and the scalars, and see if you also remind yourself what the difference between a scalar and a vector is. Okay. I'll take a pause and then I'll come and show you the answer. Okay, so, well, you should remember that vectors have a magnitude and a direction. Scalars just have magnitude, they just have a size. So, circle the scalars. Well, the scalars, you should have remembered, mass. Well, the first one we introduced was speed, distance, and time. I also told you was a scalar, and underline the vectors, velocity and displacement were the two main ones we did last lesson, and all the forces. All forces have a direction. So all forces by definition must be vectors. Starter 2, what does it mean to accelerate? Well, to accelerate, if you didn't know it before, accelerate is what we're going to cover in the lesson. To accelerate means the measure of how much you're getting faster. So it's your rate of change of, not actual speed, because it's a vector, it's your rate of change of velocity. That's actually what your acceleration is. It's rate of change of velocity. So, formula for acceleration is, this is the one we're going to be using. It's A equals V minus U over T. And what does that mean? Well, that means change in velocity divided by time. What is your change in velocity? Well, it's actually your final velocity. Minus your initial velocity. So we use U and V here because we have two velocities. We generally use, when you see this like V minus U, your V means your final velocity and U means your initial velocity. Units of velocity is meters per second squared, because it's how fast you're changing your speed, which is meters per second. Okay, so the formula that you need to know is A equals V minus U over T. So it's a slightly trickier formula, so you can check you've got it right. So it should say, this is the one you really got to know. A equals V minus U over T. We can also make V minus U equals AT. So we're just treating V minus U as one sort of block here. And we can also make T equals V minus U over A. You will not be given this on the data sheet, so this is an equation that you do need to learn. Okay. So we'll go through this one together, and then we'll give you some more examples to do on your own. A cyclist accelerates from 0 to 10 meters per second in 5 seconds. What is her acceleration? We'll have a go at doing it anyway, and then see how it matches up to what I'm going to do. First of all, I'm going to write down the formula. A equals V minus U over T. So this is, see here, that is the start velocity. So I'm going to label that U. That's the final velocity. I'm going to label that V. So it's V minus U. 10 minus 0 divided by 5. 2m meters per second squared. She's getting 2 meters per second faster every second. That's why it's meters per second squared. Okay, let's have a go at these. A ball is dropped and accelerates downward at a rate of 10 meters per second squared for 12 seconds. How much will the ball's velocity increase by? So, A equals V minus U over T. We want V minus U. Let's just try and we want the change in velocity. So V, which is V minus U. V minus U is what we're trying to calculate. V minus U equals A times T, or AT, which is acceleration is 10 times 12, 120 meters per second. That is actually the answer in this question, because they've asked you for the increase in velocity. You could assume that it was travelling initially at a 0, but it doesn't actually say that. So that is the correct answer. A car accelerates from 10 to 20 meters per second with an acceleration of 2 meters per second. How long did this take? Well, that's U, that's our start velocity. That's V, that's our final velocity. And this is A. A equals V minus U over T. And we've been asked to calculate T. T equals V minus U over A. Make sure you get these the right way round, or you're going to get a negative number here. So that's 20 minus 10 divided by 2. Do it slowly so you don't make any mistakes. 10 divided by 2, which is 5 meters per second squared. A rocket accelerates from 1,000 meters per second to 5,000 meters per second. Well, that's U, that's V. In 2 seconds, what's its acceleration? A equals V minus U over T. What's V? Well, V is its final velocity, 5,000, minus its starting velocity, which is 1,000, divided by 2. So it got 4,000 meters per second faster in 2 seconds. So it had an acceleration of 2,000 meters per second squared. Well, that's a very high acceleration. I wouldn't fancy being in that rocket. So we've done a few acceleration calculations. So let's now just look at velocity time graphs, because they're very closely connected to acceleration. One thing I'll mention here, I forgot to put the y-axis on here, perhaps on the version you're using. Maybe I put it in subsequently. But if you could just write in here velocity, and that's going to be in meters per second. So let's just look, what is a velocity time graph? Well, it just shows velocity. Oh, I've missed that other one as well. That's time. It shows how velocity changes over time, funnily enough. So what are we looking at here? Well, we start maybe take a moment, take a pause, and have a think about what you're looking at here. So let's look at this first section here. Well, we start off here at time equals 0, and over the next 10 seconds, look, we end up at 40 meters per second. This is a straight line. That means our velocity is changing and it's increasing, and a straight line means it's increasing at a constant rate. So that, in effect, is what we call constant acceleration. If you have a straight line on a velocity time graph like this going up, that would be constant acceleration. If you remember on the previous lesson, when we looked at it, I'll show you here. I just swap that back in. This line before was constant velocity, but that was a displacement time graph. This is a velocity time graph. Now, what's going on in this section here between 10 and 20? Well, before, you might remember, that was actually going to represent stationary. But this is clearly not stationary. This object is moving at 40 meters per second at the start, and it's 40 meters per second now. That's certainly not stationary, is it? What this represents here, straight line graph on a straight line, like here, on a velocity time graph, means constant velocity. Here we've got another upward line. This is also accelerating, similar to here. But can you see it's not going up as quick? It's going up at a slower rate than before. So this is constant acceleration, just as before, but it's a lower acceleration. So it is accelerating, it's just not accelerating as much as it was in this section over here. And here we go. This object goes from 60 meters per second down to 50 meters to 0 in 20 seconds. Well, I could call that negative acceleration, but I think I'm going to use the word deceleration here. So deceleration just means acceleration in the opposite direction. So I could write in brackets there, negative acceleration. So let's do some calculations. How fast was the object going after 10 seconds? Boom, go up here. 40 meters per second. No actual calculation required there. What was the acceleration from 20 to 30 seconds? Well, I'm going to go back to my formula. A equals V minus U over T. There's my final, so there's my final velocity. So that's 30, 60, minus my start velocity, 40. And how long did this go on for? Well, it's actually 30 minus 20 seconds, so that's 10 seconds, which is 20 divided by 10, which is 2 meters per second squared. What was the deceleration from 30 to 50? Same formula. A equals V minus U over T. Well, what was the final velocity? The final velocity at 50 seconds was 0. That's here. What was the initial velocity? Well, so it's 0 minus the initial velocity, which is 60. And we've got 20 seconds here. It's 50 minus 30, which is, so it's minus 20 divided by 20, which is -1 meters per second. Now that's actually fine if you want to call that. Some people like to say because it's deceleration. You could also write the deceleration equals 1 meters per second. I wouldn't be too bothered about this negative sign. They're both right. It's an acceleration of -1 meters per second or a deceleration of 1 meters per second. But either of those values would be correct for that particular solution. Please have a go at doing this extension task. You might just want to think what the scale is that you're going to use here and what scale you're going to use on here. That would be good. Okay, let's have a go at this little plenary. We've got 6 options here, 6 graphs. So let's see, velocity, they're all velocity displacement graphs. Well, let's go for this one. That is an easy one. It's got a velocity of 0 and it stays at 0. That object clearly is stationary. These two aren't stationary, but they're clearly not accelerating. They're traveling at a constant velocity. Constant velocity, both of these. This is a constant velocity of 2. Oh, isn't that wrong? This is a constant velocity or constant speed of 2. That's fine. Speed is fine. And this one is a constant speed of 4, which now just leaves us these two. Now, these two over here, I'm going to just do acceleration, acceleration, and this is a deceleration. Okay, so I've got deceleration, acceleration, acceleration. Well, look, it's gone from 4 meters per second to 0. A equals V minus U over T, which is -4, because it's gone from 0 minus 4, 0 minus 4 over 1, which is -4 meters per second squared. So that is that one. This one is doing, it's increased by 4 in 1 second, so that's 4 meters per second squared, and this one's increased by 4 in 2 seconds, so that's 4 over 2, which is 2 meters per second squared. So that's that one. And constant acceleration of 4 is that one.